to finish the book Alice in Quantumland, an allegory of quantum physics by Robert Gilmore. Today is the day when we start and hopefully finish chapter 10, the experimental physics fun fair. And mind you, fun is spelled with PH and fair is spelled with PH as well. Okay? So, as everybody joins in, the first thing I want to say, if you're watching this live or on the replay, thank you for joining me for reading. I would love to have you. Everybody is welcome. I would like to remind you that if you like, subscribe, share, or show me support with a super chat or a super thanks or anything like that, I really deeply appreciate it. I do this for us. I don't do this for anything else. So I appreciate your support, whether it's a like or a comment. Leave me your comments. I will read them. I try to say hi on the live, but if I'm interested in your opinions, and I love to have you all here. So let's start reading. Chapter 10, the experimental physics fun fair. Let me see if I can show you the illustration at the beginning of the chapter. See it here? A little bit far away. Let's see if we can move it closer. See? There you go. And it begins like this. It says, the darkness slowly cleared from about Alice. The shadows lifted from her eyes, which were immediately dazzled by a chaos of bright lights and colors. At the same time, her ears were assaulted by an assertive cacophony of sounds. She looked around and found that she was in the midst of a merry and diverse throng of people. There appeared to be all manner of folks present, in every kind of dress. She could see that some of them were wearing white coats, such as one imagines scientists to wear in their laboratories, while others in the crowd were dressed in very casual clothes or informal suits. She could see costumes from countries all over the world, and indeed from many different times in the past. There were men in Victorian frock coats with impressive bushy side whiskers, and others in burnouses or traditional Chinese costume with wide flowing sleeves and long pigtails. She saw one particularly hairy-looking individual who staggered past, dressed in untreated animal skins and carrying what looked like a roughly formed wheel, which which appeared to have been chipped out of stone. One, one the side of the On the side of the wheel, the words "Patent applied for" had been carefully chiseled. One man in particular caught her attention for some reason. She sensed some special quality about him without being able to pin down exactly what it might be. He had a pale, intense face and was dressed in the breeches and waistcoat and wide frock coat of the 17th century. Here's the fellow with the patent pending wheel. See, he's a caveman. Okay, and now we're talking about the man with the frock again. He was walking along absent-mindedly, taking a large bite out of a bright red apple. Where am I? She asked herself, speaking aloud, but hardly expecting to be noticed in the hubbub which arose all around her. You are in the experimental physics fun fair, came the unexpected response. Alice looked to see who had spoken, and found that, once again, she was accompanied by the quantum mechanic, who was walking quietly by her side. He indicated a banner stretched out across a gateway by which they had apparently just entered. It bore the slogan, Experimental Physics Fun Fair, with PH 3 times. It It does seem to be spelled rather strangely, commented Alice, this being the first thing which stuck out about it. Well, what do you expect? They are all scientists here, you know. This is the great carnival of empirical observation. Here you will find many demonstrations of physical phenomena and sideshows of experimental results. Hello, Zia 3356. Mm. Alice gazed around her and saw a splendid variety of tents and stalls, with here and there a more substantial looking building. They all carried large, brightly colored posters which vied with one another for the attention of the crowd. She read a few of them. She read a few of them, and they said, "Enjoy the thrill of particle collision! Knock out a quark and win a Nobel Prize!" And the other one says, "Hunt the neutrino!" There was a disturbance of some sort in the crowd nearby. Alice looked across and saw a balding, bearded man wrapped in what appeared to be a large white bath towel. He was shouldering his way through the crowd, hampered by the fact that he was carrying a large poster board in one hand and an incredibly long pole or lever of some sort in the other. She peered carefully at the notice that he was carrying. At the top, roughly painted out, she could just make out the words, "Feel the earth move." Below the below the erased words, she read the modified message, "See me move the world." "Who is that?" asked Alice, "and what is he planning to do?" Now I will show you the illustration. 1 second. Um, thank you, Samuel. See, this is the man with the pole or lever and the sign. And this is the whole crowd of scientists. All right, let's continue. Um, who is that? Asked Alice, and what is he planning to do? Oh, that is a well-known Greek philosopher. He is obviously intending to go into his old moving the world routine. Really? Exclaimed Alice. Does he often move the world then? Oh no, he never does. He can never find a fixed place to stand while he uses his lever, you see. As this did not appear to offer much immediate entertainment, Alice looked around for something more promising. Her attention was attracted by a stall nearby, which bore the name Photoelectric Cannon. There was a sort of stylized gun from which the player could direct a beam of light onto a metal surface. The light caused electrons to be emitted where it struck, and the idea, as explained by the stall's occupant, was to get the electrons to move a little distance to a sort of bucket where they would be collected. This seemed easy enough to Alice, even when it was explained that, to make things a little more interesting, there was a weak electric field which resisted the passage of the electrons and turned them back just before they reached the collector. After all, as the stall owner explained, there was a control which would allow Alice to increase the intensity of the beam of light to many times its present value. However, However hard she tried, though, she found that she could not get any of the electrons to travel the last little distance. She turned the intensity of the light higher and higher. More and more electrons came streaming out, but every one was turned back at the last minute by the electric field. "This is really too bad," exclaimed Alice in frustration. "I am afraid that it is what you have to expect," replied her companion. "You see, you have only been given the control of the intensity of the light and not its color. If light were a classical wave, then you would expect that as you increase the intensity, the associated disturbance would increase, and it would give more energy to the electrons that were emitted from the surface of the metal target. Um, yes, from the surface of the metal target. In fact, it is the color or frequency of the light that decides the energy of the individual photons which compose it. As you are not provided with any way to alter this, you cannot change the energy of the photons or, for that matter, the energy of the electrons which those photons will knock out of the metal surface. The stall has, of course, carefully been set up that so that this energy is not quite enough to get through the retarding electric field. When you increase the intensity of the light, you directed more photons onto the surface, and these produced more electrons, but they all have had the same energy. And in every case, it was not quite enough for the electron to make it into the collector. I am afraid that you cannot win. Alice felt somewhat cheated by her experience with all this stall and looked around for something different to occupy her. Nearby was a small tent with a sign which read, "Roll up, roll up. See the largest collection of quarks in captivity." Before I continue, I'm going to turn back the page, and I'm going to read a little blurb from our scientist, okay? Excuse me. The quantum description of the world is hardly what we would have expected. The reason for believing it is that for believing in it is that its predictions agree with experimental results. It is the only theory that can give any sort of explanation for the behavior of matter on the atomic scale, and it does it remarkably well. Um, okay. And then we left off in the roll up. But here we have another blurb from the little bald scientist. Yeah, and that's what I'm going to read now, which says the central features of quantum behavior are the detection of discrete particles and the observation of interference. The observation of quanta is shown by the photoelectric effect, the production of electrons by light falling on a metal surface. The only result of increasing the light intensity is to increase the number of photons present and consequently the number of electrons. Each photon still reacts on its own. So if the frequency of the light is unchanged, as the intensity is altered, then each photon will still have the same energy, and the energies of any electrons produced will be the same. Whatever the intensity of the light, this is quite different from the behavior expected for a classical wave, where a greater intensity should mean more energy delivered. This is true. Like if a big object falls in the water, poof, it makes a big splash. Alice and her companion slipped inside the tent, where the exhibitor was telling a small crowd how fortunate they were to see all six quirks captured and displayed for their entertainment. Alice looked at the exhibits. None of the quirks were present singly, of course. They were all assembled in pairs, each one bound unbreakably to his anti-quirk. Alice realized that this was as close to a collection of isolated quirks as it was possible to get. And after all, she thought, he did say that they were in captivity. Alice looked at the assembled quark pairs. They were assembled on a platform which had various levels, with the heavier quark combination standing on the higher energy level. She saw an up quark wiggling his heavy eyebrows at her as before, a down quark, and slightly higher up, a strange quark with flaming red curly hair. As well as these three types, which she had already met at the masquerade, there were two other hires still. One projected a captivating personality, and she saw a quick flash of light as from a display of incredibly white teeth. That is a charm quirk, the quantum mechanic um, murmured in her ear. The other new quirk was heavier yet. This one was placed quite high up, and Alice saw him even less clearly than the other particles she had met. But she got the strangest impression that this one had a donkey's head. That is a bottom quark, her companion informed her. Alice looked higher to see the sixth quirk. Do you guys understand the play on words? It is a bottom quark with a donkey face. um, uh, that is a bottom quark, her companion informed her. Alice now looked higher to see the sixth quark. There was there was the position on the platform, but it was empty. There was no sign of the sixth quark, which she was informed would be the top quark. Other members of the audience also had noticed the absence of this sixth quirk and were protesting noisily. All right, said the exhibitor soothingly. I know that he is in here somewhere. The top quirk is the heaviest of them all. So we have to look for him at high energies. But he must be here. He picked up a large butterfly butterfly net which was leaning against the pole, climbed up a stepladder, and began making wide, random sweeps of the net close beneath the roof of the tent. During this, his audience became increasingly restless, with uncomplimentary remarks being made on all sides. Gradually, the mood of the crowd grew distinctly ugly, and people began to slip away in order to write critical letters to their favorite technical journals. Come away, said the quantum mechanic to Alice. This is no place for us now. They went outside, and Alice's attention was caught by another stall, at which people clustered, throwing balls at various prizes, which they would win if only they were able to knock them from their stands. It looked very much like the sort of fairground stall which she had seen near home, except that this one there, that in this one there was a sort of fence of thin, uniformly spaced wires between the competitors and their targets. Alice watched for a while and noted that as soon as a ball was thrown, it became quite blurred, and it was impossible to see exactly where it had gone until it hit some point along the back wall of the booth. Ooh, thank you for the hearts. Thank you for the likes and subscribes. Super chats, gems, everything. Thank you for your support. Thank you for being here reading with me, everybody. I love all my people that join me on the live, but I love y'all that watch me on the replay as well. Where did we leave off now? Hmm. Here, she saw that most of the balls did just that. They hit the wall rather than any of the prices. Gradually, piles of balls built up where they had hit, and Alice could see that these piles were positioned neatly in the spaces between the prizes. Exactly right, said a voice by her ear, echoing her thoughts. The regularly spaced wires are acting to produce an interference pattern with a much greater probability for the balls being observed in some places than in others. Naturally, the minima, the places where the probability of finding balls is at its lowest, are arranged to fall where the prices are. That doesn't seem very fair, remarked Alice. Hi, Babito Malo or Bebito Malo. It is you. I try to come on live at this time. For me, where I am in California, this is 12:38 right now. So from 12 to 1 during the week is when I try to go live. Did you guys subscribe? Bebito, did you subscribe so you could watch me live? um, that doesn't seem very fair, remarked Dallas. Well, no, perhaps not. But in the fun fair, you do not expect it to be fair. He says in the fun fair with PH, you do not expect it to be fair with an F. After all, the man who runs the stall has to make a living, so he does not want to give out prizes too often. Of course, there is still probability of the ball being observed even at the minimum. But so some prizes do get won, but not too many. In Florida, cool. Alice still felt that it was not quite right somehow, but before she had said anything further, her attention was caught by a large pavilion a little way off. It was surrounded by a huge glowing sign which said, "The Great Paradoxus, Spooky Action at a Distance." Below the sign, there were a number of large posters strung across the front of the building. Extraordinarily astounding, paradoxically incomprehensible, rather surprising on the whole, with a bold E, bold P, bold R, EPR. Alice and her associates made their way Alice and her associate made her way to this exhibit and joined the crowd, which was streaming in through the doorway. Within a long, high Within was a long, high-ceiling enclosure with a raised platform in the center. On either side were a pair of short ramps leading up to doors at the two ends of the building. On each ramp stood a short metal cylinder, which pointed with a pointed nose and stubby fins at the back. Cylinder with a pointy nose and stubby fins at the back. On the central platform stood the great Paradoxus, a tall figure with glossy black hair, a spiky waxed mustache, and a flowing black coat. A flowing black coat. Um, Good evening, ladies and gentlemen, he greeted them. Tonight, I plan to conduct a little experiment on the reduction of amplitudes, which you may find to be of some interest. Here on the platform besides me, he continued, you see a source of transitions which will release two photons in exactly opposite directions. As you know, if you were to measure the spin of the photons along some direction of your choice, you would find them to have a spin either up or down, with no intermediate choice possible. Alice had not known that, though she had heard talk of spin up and spin down electrons, but All the other people present were nodding their heads wisely, so she assumed it must be all right. Oh, water break. Please. Thirsty. So she assumed it must be all right. As I say, if you were to measure the spin, you would find it to be spin up or spin down. But if you do not measure the spin, then there will be a mixture, a superposition of states having different directions for the spin. Only when you make a measurement of the spin will the amplitudes reduce. One will be selected and one will no longer be present. Now, he said abruptly, the source which you see here makes its transitions from states which have no spin at all. So the total spin of the two particles produced must also be zero. That means, he explains kindly, that the spins of the two photons must be opposite. If one has high up, then the other must have what high up? If one has spin up, then the other must have spin down. But mark you, the spin direction of the photons is only selected from the superposition of states when a measurement is made. That is the usual understanding. Thus, you see that when a measurement is made on one photon with the discovery, let us say that it has spin up, then the amplitude of superposition for that photon will reduce to the appropriate state. However, Paradoxus continued, drawing himself up to his full height. At the same time, the superposition of the other photons must reduce also, because we know that this photon must have the opposite spin. This must happen however far apart the photons might be at the time, even if they had arrived at different stars in the sky. In this demonstration, we will not be making our measurements quite far apart, quite so far apart as that. He smiled at his audience. I now call two volunteers, two trusty and reliable experimenters who will agree to travel to the opposite ends of Quantumland and make our observations for us. Hi, Sid, New. I'll call you New. Um, Hi. This book is called Alice in Quantumland, as you see here on my green screen. It's an allegory of quantum physics by Robert Gilmore. You can watch the other chapters on replay. I've read it live, and this is chapter 10. So the final and last chapter. Let us continue. Oh, in this case, it tells us, see end of chapter note 1. End of chapter note 1. Let me see if I missed any illustrations to show you. No. End of chapter note 1. End of chapter note 1 tells us there have been many attempts to set up an experiment which would contradict the more extreme predictions of quantum theory, but so far, quantum mechanics has always been vindicated. An example is the aspect experiment to investigate a form of the Einstein-Podolsky-Rosen (EPR) paradox. There are various forms of this paradox which involve measurements of particle spin, the strange quantized rotation possessed by elementary particles, such as electrons and also photons. The paradox treats the case of a system which has no spin, but which emits two particles that do have spin, and which travel directly away from one another. The restrictions of quantum theory tell us that a measure of the spin of either particle can give only one of two values, spin up or spin down. If the original value has no spin, then the spins of the two particles must compensate. That is, if one is spinning a spin up, the other must be spin down, so that the sum of the two gives a total spin of 0. If you measure if no measurement is made of the particle spins, then quantum mechanics says that they will be in a superposition of spin up and spin down states. When a measurement is made on the spin of one, then at that point, its spins will be definite, either up or down. But at the same time, the spin of the other particle becomes definite also, as the two must be opposite. This would be true no matter how far apart the particles move, since they separated. This is, in essence, the EPR paradox. There was a buzz of argument and discussion from the assembled crowd. Eventually, two people were pushed forward. Both were dressed in long frock coats and narrow trousers, and both had bushy side whiskers. Both wore waistcoats, each with a gold chain attached to a watch, which its owner had obviously checked recently against a reliable standard clock. These two are actually identical to one another, since only particles are completely identical. But, oh, it says these two were not actually identical to one another, since only particles are completely identical, but they were certainly very much alike. They were obviously both honorable, honest, and reliable, as well as being competent and conscientious observers. If they were to say that they had seen something, no one would dream of disputing it. Paradoxes handed to each a polar- polarimeter, a device with which they might measure the spin directions of the particles. With military precision, each stripped the instrument he had been given, examined it to make sure it had no unusual features, and quickly reassembled it. Mm. The showman then summoned two attractive female assistants who escorted the volunteers to the metal cylinders and opened a door in the side of each. For some reason, each of the two observers then put on a tall top hat before he squeezed himself into the cramped space within. The assistants closed the doors, lit a fuse at the rear of each cylinder, and stepped hastily back. With a roar, the stubby rockets rushed up the ramps, through the doors at the end of the pavilion, and arched over the horizon, making for the opposite ends of Quantumland. And now we wait for them to arrive, remarked the impresario. As soon as each is in position, we will send message through his telegraph line. He indicated two bells which stood on small tables at either end of the platform. Everyone looked at them, waiting for them to ring a signal that the show might proceed. It was a long wait. Everyone seems very patient, remarked Alice, who was beginning to feel a bit restless herself. They have to be, replied the quantum mechanic. Experimental scientists all learn to develop patience. Finally, the bells rang for one, then shortly after the other. This indicated, oh no, finally the bells rang. First one, then shortly after the other. This indicated that both observers were in position, and with a dramatic gesture, Paradoxus opened the window at either end of the photon source. Two by two, the photons went rushing off in opposite directions. After some time, he closed the windows again. There was another long pause. I wonder what we are waiting for now, thought Alice, who felt that the entertainment might move just a little faster. There was a flapping of wings. Through the door at one end of the building flew a carrier pigeon, which was expertly caught by one of the assistants. Not long after, a pigeon arrived through the other door, and the message carried by both could be compared. Paradoxus displayed the two messages, which showed a perfect correlation with a spin-up and photon going to one side invariably, with a spin-up photon going to one side invariably, accompanied by a spin-down version detected at the other, even though the two detectors were too far apart to have had time to exchange any information. Wow. This is for tomorrow, y'all. I am sleepy today. Sorry, but my time is running out as well. I'll see y'all tomorrow, okay? Subscribe so you can see me again. Give me support. Give me a like. Leave me more comments. Love y'all. Take care.